We basically teach the evolution of technology from the earliest primates, or even earliest hominins, but even pre-hominin primates, like early monkey-like creatures. Their use of tools and technology through time, right up to the Iron Age. And the idea is, because we're teaching ancient technology, one way that we get at that is through experimentation. So we do experiments in the present. We sort of have uniformitarian assumptions that the laws of physics are the same now as they were in the past. So if we perform certain kinds of controlled experiments, we can actually use that to understand the way similar phenomena may have operated in the past. In other words, the way artifacts were created, the way technologies performed, whether they were efficient or what materials were needed and so on. So the assessment that I have in ancient technologies is to actually conduct an experiment for themselves using principles that we've covered over the course of the 10 or 11 weeks up until that point when they start to do it themselves. And not only that, but to actually document the experiment using YouTube-style video. So to give, like you would in an essay, aims and background, rationale, sort of previous research, but then to actually show yourself, in this case the student, doing the experiment, coming up with results and presenting conclusions. And this works really, really well in a 10-minute video. In fact, I've actually uploaded, with their permission, maybe 20 or 30 of these videos from previous students. And not only that, but some of them have been so novel they've actually led to publication. Yeah, I think it's about scaffolding. You definitely have to give them all of the tools that they need, and I don't mean the stone tools. I mean the tips of the trade on how to build a video. You need to invest a fair bit of time in making sure everyone's confident that they can actually pull off the task. What they do each week in class is, as a group, they do an experiment under my supervision, where they've got a hypothesis and a rationale and the archaeological context spelled out for them. And then literally they sort of have steps and stages of what they're going to do in the prac. Then they collect the data as a group, they pool their data, and then the data goes on Blackboard, and then for the following week or the week after, depending, they have to then analyse that data using statistics, basic statistics, and present results in their worksheet, which we then mark. So there's no substitute really for doing some reading and thinking, and the short essay that they do midterm, the idea is just basically to get them to reflect on a particular topic, which from memory is about how can we use experiments to better understand the past, and what are some of the strengths and weaknesses of that approach of analogical reasoning. And for that they have to give 2 case studies. So it just gives them, well, it forces them, let's face it, many of them are interested in, to read literature, find some good case studies and try and learn from that in advance of them doing that for themselves. But it's not as if we just throw them out there. We have a list of potential topics. They can come and see us and explore things. And we have 2 in-class discussions before the experiments. They start the experiments, in which they get to run ideas past us. Often it's just like, I don't know what to do, but I'm really interested in blah. So we'll just workshop a little idea for them, and they'll come back the next time, having done some reading, and then we kind of refine it, and they're ready to go. In the lectures, we use a lot of video, for instance, both web images as well as documentaries that have been made about other people doing experiments. And people have commented that they really love that aspect of the course, actually getting to see other people doing experiments. But we actually do a session in the class where I show them how to build the video itself. So I think we have like a full hour on that, where I basically use various tools. It might be iMovie or I think there's Windows Movie Maker or something, and we just show how you actually build this thing. Putting in speech and overlaying a soundtrack, incorporating video and stills, putting text in and so on. So I think by the end of that they're reassured that it's not too hard. And then they have the option of giving that to me on a USB or a CD or DVD, or they can even upload it straight to YouTube and then just send me the link. And if I like it, then I'll just keep it on there. You need to obviously we don't provide all the materials, but some materials that might be hard to get. You can't expect people to buy expensive items and things like that, for instance. So if there's anything like that, we generally make it available, and of course funds. We have a special experimental facility down by the river called the ATARC, where they can go and do those sorts of things, and we have heaps of materials down there that they can use as well. The other time commitment, of course, is time spent down at the ATARC with the students helping with the projects. And fortunately, though, I do get a facilitator for that course, because there are OH&S issues, obviously, if you're pouring molten bronze or firing arrows. We need to have extra supervision, and luckily, I've always had facilitators who are very hands-on and happy to help out, so it hasn't been as taxing as it could be. We've had up to 60 students in the past, which has been very challenging, so what we've had to do each year is to rerun the prac 3 times. It's a 1-hour prac, which is rushed at the best of times. But I don't see any way around it. It's either that or half of them miss out. So I think any more than 60 would be unrealistic. Well, I just think that experiential archaeology is a very visual thing as well as a hands-on thing. Also, by creating a video of them doing it, I can actually see them doing it, so that they can't fake the fact that they went off and raised a megalith, in their backyard. I don't know if they did or not. If we actually film them doing it, or they film themselves doing it, then we can actually see the process. There's very little opportunity to plagiarise, or I guess the only thing they could... Well, in fact, this is even allowed within the experiment. They can rerun someone else's experiment if they want to. It doesn't have the novelty aspect, and they know that. But if they don't have the X factor, then there's no extra marks for that. But they can get by with a fairly sturdy assignment that way. Maybe they can vary 1 or 2 things just to make it a bit novel. So a lot of people do that. I don't see that as plagiarism. It's it's an independent test. It's a rerun of an experiment. That's fine. It's probably more in the worksheets where sometimes we find people copying off each other. We give them a warning and they stop doing it. Because it's group work. This is the sort of thing that can happen a lot. But they work together and they end up feeding each other answers, and it's not okay, so they have to stop it, and they do stop it. So we've never had anything beyond that. In the context of a video, they're not presenting vast swathes of text, so they have to paraphrase. They have to use their own words. So I think it does deter that kind of plagiarism, for instance, at least. It's engaging and fun for them. They go outside of their comfort zone. There's no doubt about that. Some of them get the disadvantage would be, I guess, to start with, they get quite stressed about it. A lot of them. It's something totally new for them. They've never done it before. The whole idea of coming up with your own project, often for undergraduates, is challenging. Sadly, some people just never rise to the challenge. They hand something in, they might pass or fail, but it's not like we get a lot of fails. Maybe 1 or 2 a year, like any subject. So, on the whole, I'm really delighted with the way it's worked. I thought at first it would be way too challenging, but it hasn't worked out that way at all. It's actually been... I think for most people who've given me feedback, they've said it's like the best course they've ever done. Like to do something like this in a university setting is an opportunity they never thought they'd have. So again, it was about giving them a hands-on task and trying to translate theory, principles, archaeological case studies and so on that they've learnt in class into something that they can actually do to reinforce that learning for themselves in a hands-on way. And experimental archaeology is a fantastic way of doing that. But it really gives them a chance to think laterally, to think freely about what they want to do, to explore a topic, to read as widely as they want. Usually it's not that widely, but widely enough to kind of get the key concepts together. To then actually design an experiment using the principles that we've taught again and again in class, and then to carry it through for themselves. And I think for some of them it's definitely quite challenging, but for those that are quite... can take the initiative and go for it. They can achieve amazing things, and I think they're really astounded themselves as what they've achieved as a result. But many of them are so enthused by it that they actually want to go on and do that kind of work for their honours and their PhDs. As I said, some of them have even gone on to write up papers for publication, 2 of which I know have been published.